let's veer away from money now and let's talk about some uninhibited growth and decay. So we've got a population of mosquitoes, which is all exciting, that follows this pattern. So there's 1,000 mosquitoes initially, and then after 1 day we have 1,800. We want to find the growth rate. So this is going to use our PERT formula again. So A equals P times E raised to the RT. Our A would be 1,800. So I'm going to go ahead and put 1,800 in. Our P, or our principal amount, what we start with, is 1,000. So I'll put 1,000 in. Our rate is what we're looking for, and our time is just 1 day. So I'll divide both sides by 1,000. I'm going to zoom in a bit. And that will give me 1.8 is equal to E raised to the R. And then because the exponent has the variable, that tells me we're going to have to use a log. And the inverse of base E is natural log. So our rate is going to be the natural log of 1.8, which if I type that into a calculator, I would get approximately 0.5877 or 58.77%. So now we're going to go to the next part, and it was actually important that we found that for this first part because we need that growth rate in order to solve the next part. So they ask us, how long is it going to be until there are 10,000? So we're trying to figure out if we end with 10,000 and we start with 1,000 again, what would our time be? So we're going to put that rate in and put our time right here. So we'll go ahead and divide by 1,000. So that gives us 10 is equal to E raised to the 0.0. Well, I wrote the wrong numbers, sorry. Just noticed that. So it should be 0.5877 because it is 58%. So 0.5877 T. Just like the previous problem, since the variable is in the exponent, we're going to have to get rid of the base E. So you do that with the inverse, which is natural log. So we've got natural log of 10 equals 0.5877 T. And the final step would be to divide by that rate. And then just type it into your calculator. So I'll go ahead and do that. So natural log of 10 divided by 0.5877. Yep, sorry, I just took a second. 3.918 days. Perfect. And that would be our solution. So let's go ahead and do another one. Once again, this is going to be uninhibited growth or decay. This one's a little tricky. We're going to have to actually go through it twice. So we've got radioactive material, in Ukraine. You've probably heard this story. So it was contaminated by iodine 131, which has a half-life of 3 days, or 8 days. Wow, I can read. Okay, half-life is 8 days. If it is all right to feed the hay to cows when 10% of the iodine, 131, remains, how long do the farmers need to wait to use the hay? Okay, so before we can actually answer the question, we have to find the rate. So the actual rate. So we know the half-life is 8 days. Now, regardless of how much we start with, let's say I start with 1, that means we'll have a half remaining in the end, right? It doesn't matter how much I start with. But we need to find that rate in order to figure out this 10% question. So I have a half is equal to E, 1 times E, or just E, raised to the 8R. So I'll go ahead and take a natural log of both sides to get rid of that base E. So natural log of a half equals 8r. Divide by 8. And we get a rate that is, let me type it in. And we're dividing by 8. There we go. About negative 0.0866, which makes sense because it's decaying. Decays are always negative rates. So now what we need to do is figure out, we want 1/10 of it remaining, right? So if we have a principal amount of 1, because it's 10%, we got to figure out how long it would take. So we've got our rate now. We just need to find the time. So we've got 1/10 is equal to e raised to the negative 0.0866 t. Once again, we'll take a natural log of both sides to get rid of that base e. Since they are, oops, 6, there we go. Since they are inverses. And then I will go ahead and divide both sides by negative 0.0866. And we'll plug that in to get our final answer. So negative 0.0866. I get approximately 26.589 days. And let me just double check, yes, because we were doing days. You always want to make sure you're using the right units. And that would be our answer. Let's do one more problem. So number 15, suppose that 6 American bald eagles are captured and set free. So we've got 6 initially. We'll see if that's important. Probably not, based on this. So they've given us this equation right here. And they want us to know how long until the population reaches 50 bald eagles. So yeah, that actually wasn't important, the 6. But the 50 is, because that's our population. So all you're doing, you don't have to know anything about this. You just need to put 50 in for the population P and set up this equation. And then solve. Which, this one's going to be kind of a tough one. There's a trick I'm going to use. So I'm actually going to multiply by the denominator and then simultaneously divide by both sides by the 50. So multiplying both sides by the denominator and then dividing both sides by 50. So that gives you 1 plus 83.33 e to the negative 0.162 t is equal to 500 over 50. And then I can subtract 1 from both sides. So 83.33 e to the negative 0.162 t is equal to, well, 50 over 5. Yeah, 50 over 5. Had to make sure I was saying that right. Is 10. And 10 minus 1 is 9. So this is 9. I'm going to divide both sides by 83.33 because we've got to get the base E alone. And I'm actually going to move this up here. Well, not yet, actually. I didn't realize I still had space. So I have e to the negative 0.162 t equals, and I'm not even going to figure out what that is because it's going to be a decimal, and I want to get as exact as possible. So at this point, I'm applying the natural log because this is base e. And remember, natural log and base e are inverses, so they cancel each other out. So we get negative 0.162 t equals natural log of 9 over 83.33. And then I just divide both sides by negative 0.162. And I'm just going to type that in to find my time. And when I type that in, I will end up with 13.738 years. There you go.